let's take a look at some examples of compound interest. Let's start with this one. Example A. Example 1A. $1,000 is invested at 10% per year for 3 years compounded annually. Now have your notes handy with you, and especially have this table from the previous video on your notes, or just have it handy. Okay, so one important thing when you see problems that have to do with compound interest, immediately you know them because they tell us. It says compounded annually. So let's underline this. If it says compounded annually, then well, let's write down the formula for compound interest as a reference. So you have A equals P open bracket 1 plus I to the power of n. Okay, and let's start collecting our data. Right, so P is equal to, well, $1,000. I, we need to collect I and n. So I is equal to 10%. So that means we're going to turn it into a decimal. So this is going to be equal to 0.10. Okay, right? Or 0.1. It says compounded annually. So we go to our chart here. It says compounded annually, once per year. What do we do with I? Well, nothing. So we leave it the same. What do we do with n? I'm kind of jumping ahead. We do nothing as well. Okay? So, and of course, so we leave it. N is going to be equal to 3 years. And since it's annually, it remains unchanged. So now all we have to do is simply substitute the values and find out what our answer is going to be. So $1,000 times 1 plus 0.1 to the power of 3. And then one thing I suggest is if you are gonna try to put all of this calculation in your calculator, I would suggest start by doing the stuff that is in the brackets first, all that to the power of 3, and then times the principal. Okay, I'm gonna demonstrate that there's one very good reason for that, and that is that sometimes students try to put it all in one line in this order, and what ends up happening is that sometimes the principal is raised to the power of 3, but that should not be the case. Okay, in any case, the answer for this is $1,331. So instead of going line by line for 3 years, we just use this formula, and that's it. That's our answer. So let's write that here. Therefore, okay, let's take a look at another example. Example B, and that says $5,000 is invested at 15% per year for 6 years, compounded semi-annually. Once again, have that handy, but semi-annually means twice a year. So let's keep that in mind. First, I'm going to write this down as a reference, since we know it's compound interest problem. So we have to use the compound interest formula. And let's collect our data. What's P, what's I, and what is N going to be? So P is our initial investment. It's $5,000. I is 15%, so 0.15. But it says that it should be compounded semi-annually. If we refer to our chart, semi-annually means twice a year. So what do we do with I? With I, we divide by 2. So we take this and we divide it by 2. What is that going to be equal to? So 0.15 divided by 2, that's okay. 0.075. And of course, if it's for 6 years, you take 6, and it says semi-annually. So what do we do with n? We multiply by 2. Semi-annually, we multiply by 2 for n. So 6 times 2 is equal to 12. So now we have all the information that we can use to find what our future value will be. So $5,000 times 1 plus 0.075, be careful, to the power of 12. And once again, you can do it by parts too. In fact, I might demonstrate that now. Let's do this, right? Well, we know that inside here we're going to get 1 plus this is going to give us 1.075 to the power of 12. And now let's do this part first. 5,000 times 1.075 to the power of 12. Now, in your calculators, you got to find out what that key is going to be. And I'm getting a bit stuck as to where exactly is that. Oh, right here. So y to the power of x to the power of 12. So 1.075 to the power of 12. That gives us 2.3818. Okay, I'm trying to put the more decimals the better, the more accurate, and you can round it off towards the end. And then this times 5,000, that gives us 11,908 with 90 cents. Okay, so that's our future value.